Hey everyone, welcome back to Cruise class. As promised, in today's class, we'll be looking at an example of calculating the coefficient of correlation between two variables. Now, we're going to use the same example that we used for our scatter diagram video, which would be the number of sales calls each agent made versus the number of items that specific agent sold. Now, I'll leave a description in this video for that example so you guys can look at the table and see what I was talking about. Now, remember, X would be the number of sales calls made, while Y would be the number of items each sales rep sold. Now, we want to calculate how strong the relationship between these two variables are, the X and the Y. So the first thing that we need to do is set up 5 columns. The original X column, the original Y column, a column that is X multiplied by Y, a column that is X squared, and a column that is Y squared. So for the first example, I think this was John. I think his name was John. He made 20 calls and he sold 30 items. Now, as you can see, XY would be 20 times 30, 600. X squared would be 20 squared, which is 400, and Y squared would be 30 squared, which would be 900. And we have filled out this column. Now we have 5 more. As you can see, all the information is there. So all we do is follow the same procedure for each row, and then we will then see X, Y, X squared, and Y squared. All these columns need to be completed. Now, after we complete each column, we're going to sum each column. So when we add up all the X, we get 130. When we add up all the Y, we get 260. We add up XY, we get 6,300. We add up X squared, we get 3,500. And we add up Y squared, and we get 12,200. These are the important values: sum of X, the sum of Y, the sum of XY, the sum of X squared, and the sum of Y squared. Now that we have all those information, we need to now find the value for N. N is simply the number of data points. So N will be 1, 2, 3, 4, 5, 6 data points. So with that being said, we can now calculate the coefficient of correlation, R, using the formula. We were introduced to this formula in the previous lesson. Now what we will need to do, N, which is 6, multiplied by the sum of XY. The sum of XY is 6,300. And then we have minus the sum of X, which is 130, multiplied by the sum of Y, which is 260. And then the square root, open bracket, N, multiplied by the sum of X squared. So N is 6, multiplied by the sum of X squared, which is 3,500, minus the sum of X all squared. The sum of X is 130, and then we square all of that. Close the brackets, multiplied, as we see. N again is 6, multiplied by the sum of Y squared, which is 12,200, minus the sum of Y all squared. The sum of Y is 260, and we will square it all. That's what we have. So when we calculate the numerator, 6 times 6,300, as you can see, we're left with 37,800. 130 times 260, 33,800. And when we work out this left bracket, we get 4,100. When we work out this right bracket, we get 5,600. So when we multiply both and square root the answer, we will get 4,791.66. And when we minus 37,800, or rather, when we say 37,800 minus 33,800, we end up with 4,000. So after dividing, we see that the coefficient of correlation, R, would be equal to 0.83. And according to our scale in the previous video as well, we learned that was a strong positive correlation. So therefore, the variables sales calls and items sold have a very strong bond. They have a very strong relationship. So that is not necessarily saying that they have a cause and effect relationship. However, it is indicating that the relationship between them is very strong. So the number of sales calls made and the number of items sold have a very strong correlation of 0.83.